Welcome back. Now we are going to focus on using the quadratic formula to solve quadratics. Yay, finally, to the shortcut formula, the formula that works for all of them. I highly recommend getting really good at this, because this will work for complex roots, this will work for irrational roots, and it works for the rational roots. So the ones that factor, we could have plugged the numbers into this, gotten the results, and then we just have to move the numbers back over to get the factors. Feel free to come to office hours and ask me about that, especially when you guys get to that section on crafting polynomials. All right. So 2d squared minus 3d plus 1. So now that we're going to use the quadratic formula, I'm going to write a, b, and c down, which is why this is in terms of d, so it's not confusing. If you want to use capitals instead, just so it doesn't look like any variable that you have, that's fine. I'll just go with normal lowercase though. So our a number is 2. The b number is a -3. And the c number is a +1. Now this is where having the quadratic formula memorized is nice, because you could either write it down on the paper right now, or as you get used to using it, like you just go through saying it, but you put the numbers in their spots. But there's nothing wrong with rewriting the formula, so I'll go ahead and rewrite it once. So x equals -b plus or minus the square root of b squared minus 4ac all over 2a. All right, now we just fill it in. Now, there's a couple of ways you can work with substitutions. One of the ways, like when you're not as familiar with it, I'm going to go through and write everything in the formula except the letters. And wherever the letters are, I'm going to put a set of parentheses with a space for a number. Told you. All right. So now A shows up. Let me go with blue here. It's right here and right here. So we're going to put a 2 here and a 2 here. And the B is -3. B shows up in 2 places. So we have a -3 in little set of parentheses and the negative from the formula outside the parentheses. And then a -3 inside parentheses, and then that is going to be squared, which means the b squared part is always positive. And then finally, our last little guy here is that c, which is just a 1 sneaking in there. Normally it's a that's 1, but it's fine. All right, so what I want to talk about with what I just did, by writing all the stuff that comes from the formula and then writing the parentheses in, like I've done safe substitution, I've got my parentheses around everything, and I haven't misplaced the negative or the a on the bottom. Like those are common mistakes that you make when you're mostly familiar with the formula, but you're not as fluid with it as we would like. So there's nothing wrong with writing the formula out every time. I know it's a little tedious, but if you write it on every problem, then it starts muscle memory, you remember it more. And if you say it to yourself, then you hear it every time and it becomes easier to memorize. So that's what I would recommend. It's also good memory tricks for other classes. All right, so now that all the numbers are in here, I highly recommend the use of a calculator in certain ways. So if your calculator can handle simplifying square roots, then by all means, type in the whole square root with the stuff under it. If your calculator does not reduce square roots for you, then just type what's under the radical. Crunch up and figure out what that number is. In this case, it's not that bad. -3 squared is +9. 4 times 2 times 1 is 8. So this is 9 minus 8, which is 1. So we now have the negative becomes plus positive. So this is now 3 plus or minus Let me figure that out. That's the square root of 1 all over 4. Square root of 1 is just 1. So this is actually, and then there's a couple of ways to write it from here, but what I usually do is I kind of split it into two separate lines. So this top one is going to be 3 plus 1 all over 4, and the bottom one will be 3 minus 1 all over 4. Because this actually works out, so we want to go ahead and just crunch through each one separate. So 3 plus 1 is 4. 4 over 4 is 1. So one of our solutions is the whole number 1. 3 minus 1 is 2. 2 over 4 is 1/2. Our other solution is 1/2. Now I want you to rewind. This was actually in terms of D, so each of these actually should have been a D. So D equals 1 or 1/2. Now you might ask, well, how do I get the factors out of that? All right, let's take a look. So I'm going to write it here. So that is D equals 1. Now remember, when we get factors, it is because it is equal to 0. Once it's in the factored form, we set each thing equal to 0. So I need this to equal to 0 to see what the factor could have been from before. So in order to equal it to 0, I'm going to 0 out the number side, which means I'm moving the number back. So we have D minus 1 equals 0. So if I wanted to know the factored form from the result of the quadratic formula, that is potentially one of the factors. And I say potentially because if the original equation was all multiplied by a common factor, like everything was doubled, then we're not going to see the double part in our factors. And then sometimes 1/2 would be what you would see. Usually though, we're going to multiply by the denominator. So this D equals 1/2 is also the same as 2D equals 1 or 2D minus 1 equals 0. And that 2D minus 1 is the other factor. If you multiply these two guys together, you do in fact get back to 2D squared minus 3D plus 1. So this is how you can use the quadratic formula to generate the factors, but you have to double check to make sure that the number part up front, the A number is going to work from this. The C number is going to work from the multiplication. That's going to check to make sure like you moved denominators correctly. And then you just make sure you get the B number by, so that'd be -1 times 2D, -2D, -1 times D is -D, -2D, and -D is -3D. Checks. But the answer to this, because it has solved the equation, is the 1 and the 1/2. So we have 1 comma 1/2 or 1/2 comma 1. But those are the two things D could equal based on the original equation. All right, this is just a preview for in the future. There is a question where it gives you the roots and it asks you to backtrack to what's the polynomial or a polynomial with those roots. And one of the ways to do it is you get the zeros back, then you take each of those factors, the stuff in parentheses I got here, and then you box it, multiply it all together, which I like to use the box method for, especially if there's square roots or i's. And then you have a polynomial with those requested roots. So there are some weirder problems where that can be useful. All right. So same song, second verse. Z squared equals 5z plus 1. This is not equal to 0. First step is always make it equal to 0. So this is going to become z squared minus 5z minus 1 equals 0. Now I habitually keep the squared term positive because having it negative makes the denominator of the quadratic formula negative and it gets weird. We're going to see a problem in a sec where it starts negative and then I'm like, we're going to fix that first. All right. So hey, we got two 1s. A is 1 and our C is -1. So we got to look out for that negative. And then our B is a -5. So we got another negative start. Now earlier I wrote x equals because that is just my habitual, that's how it starts. But our variable here is actually z. So instead of x equals, we should actually write z equals. But if I was grading and you accidentally write x equals, I wouldn't take off points. I don't know what your college algebra professors would do. I do know most professors, though, are pretty sticklers about you should have a variable in front here. You shouldn't just write equals and start doing the quadratic formula. It's equal to something. In this case, z. So z equals negative b, so that is negative 5 plus or minus the square root of b squared minus 4 times a times c is -1 all over 2a. I told you I do it every time. It's just fun to sing. Negative 5 now becomes positive 5 plus or minus 5 squared, negative 5 squared, sorry, is 25, positive 25. Negative 4 times 1 times a -1 makes this positive 4. 25 plus 4 is 29, or again, just crunch everything under the radical on the calculator, then write that down here, and then you can take it to the side and see if it breaks up. 29 is actually prime, so yeah. All over 2, there's our solution. I can write it as 2 separate things, but that's all she wrote. Now, if I had to turn this into a factor to work with, it'd get a little ugly, but you can do it. So I'm going to do that off to the side, but feel free to fast forward if you're like, I just don't want to see that right now. So it's all over 2. And you usually don't have to do it with the denominator. They almost always don't put a denominator on these in college algebra. But if there was, you just multiply by it. So now we have 2 z's. And then I'm going to move the other guys over. So it'd be -5 and minus the square root of 29 equals 0. And that is a very weird factor, but it is a factor. The other side, if I did 5 minus the square root of 29, the factor would actually be 2z. The 5 here would still be -5, but this would be plus the square root of 29. And what we actually end up with then is a very weird difference of squares. But if I multiplied those two guys back together, I would get 4 times this whole thing. That's the other reason why we usually don't deal with fractions, because I'd basically multiply them and then divide it by 4 so that it would multiply back to that 1. Meh. Problems for the future. They have to write the problem a particular way so you figure out which way to go. Usually, though, this would get you to where you need to go. A polynomial that has the requested roots, and the other qualification is usually integer coefficients. So anything that has a square root or an I, you have to pair it with its conjugate in order for the product to no longer have square roots or i's. Which is why we focus so much on that a squared minus b squared. The product of conjugates is the difference of squares. So the square gets rid of I, the square gets rid of square roots. That's why it's so useful for us in these problems we do. All right. So now, -y squared plus 2y equals 1. So we can go about this 2 ways. Since the a term is negative, we could move everything right instead of left. So the 0 ends up on the left. Totally fine. Or I'm going to move this stuff from the right to the left, so the 0's on the right side like normal, and then I'm going to get rid of that negative sign. We could plug it into the quadratic formula this way. The only catch is it kind of, if the a number isn't positive, the answer you type into Alex may get grumpy, because having a negative on the bottom messes with the b and messes with the radical a little, so it just gets a little confusing. It's not wrong. It would crunch up to the same number. It just, I don't know if Alex was programmed to handle it. Probably was. It's actually much better putting together. Uh-oh, sneeze. have extremely loud sneezes as whack up the microphone. You're welcome. Also, if you're not from around here, go out and enjoy the cold weather while it's here. Granted, up in San Marcos, they do get cold weather more because they're up in the hill country than me down in San Antonio. We get like 6 cold days. But Lord help us if there's ice. The whole city shuts down. Not even kidding. All right. So I don't want to deal with that negative. No way. So I am going to, you could actually multiply by -1 or divide by -1. I use divide just because multiplying right's funny. Whereas the divide right's underneath. But it really doesn't matter. You would get the same result then. Y squared, now it is minus 2y. And then this becomes plus 1 is equal to 0. Some of you guys may be like, hey, that's a thing. It is a thing. We're still going to do the quadratic formula so you see what happens when it's a thing. And then at the end, we'll define which thing I'm talking about. So our variable is y, so we're going to start with y equals -b, so -2. And after a while, you could just write 2 once you're really comfortable with the formula. But sometimes if you do that, then you're going to ask yourself, wait, did I do the negative? And if you just see the 2, you might think, oh, no, I didn't because I don't see 1. And so you might put -2 and then your answer's off. So that's why even though I know this is +2, I'll still write -2 because if I look back through my work, I'm like, oh, no, that's correct. It should be +2. Plus or minus square root of b -2 squared minus 4 AC, all ones, yay, all over 2a. So -2 is now 2, plus or minus -2 squared 4, minus 4 times 1 times 1, 4, is 0. We actually got this earlier with completing the square when we got a 0 before we would square root. All over 2. So 2 plus 0 or 2 minus 0 is the same thing. This is a double root. This is what it looks like when you get a double root out of the quadratic formula. So we are just going to get, we get 2 plus 0 over 2, and we get 2 minus 0 over 2, both of which equal 1. So this is one of the reasons why we call it a double root, is we got the same number from the 2 different answers that the quadratic formula produces. So when this happens, it means the original was actually a perfect square trinomial already. In fact, this one would factor to, the purple would factor to y minus 1 times y minus 1. But in this case, even though it's a double root, we only write the number once when they ask what's the solution. You just say 1. All right. Then we got this ugly mess. Says all sorts, why did you do this? I didn't. I pulled it out of the book. A book. I don't know if it was your book. So we got to clean it up, move everything to one side, then quadratic formula. All right, so we got 2x squared now plus 2x times 3 would be 6x's equals -2x plus 5. And then since the 2x squared is positive here, I'm going to keep it here and move the stuff on the other side to this side. So instead of -2x, we're going to plus 2x plus 2x minus 5 minus 5. I lined it up with the like terms. So this is now plus 8x and the minus 5. And now this side is the desired and required 0. Yay, it's actually in terms of x for once. So x equals -b plus or minus the square root of b squared minus 4ac all over 2a. Like I said, when you get used to it, it's just like a process. You do the thing. I like to sometimes double check that I didn't screw up my negatives. Sometimes your brain gets tired and you might swap some of the numbers for some reason. It's weird. But like in one spot in the formula, you may write B instead of A or A instead of B. So just be on the lookout if the answer comes out and you're like, that is so bizarre. So here the 8 was positive, so it will now be negative. 8 squared for A and C. And then this is a negative, so this product is going to be plus. So we're going to have 8 squared plus this result, all over what will be 4. So we are probably going to see this answer reduce, which is very, very common. A lot of times they reduce by 2, like everything becomes divisible by 2. Sometimes it's everything's divisible by 4. But in order to do that reduction, the radical has to reduce. So just because the 8 and the 4 that's on the bottom have a common number, we could divide them both by 4. If we can't do it to a number that comes outside the square root, then we can't do it. So if we can do it, you are responsible for doing it, but if you can't do it, you don't. So just because negative 8 divided by 4 would be negative 2, it does not mean we're going to get negative 2 plus or minus, and then this is 64 plus 8 times 5 is 40, 64, and 40 is 104. So 104 looks big. It also, you don't go 104 divided by 4 and call it good either. 4 is outside the radical, 104 is inside the radical. You don't interact the numbers that way. So there is a weird way to shove 4 into there, but it doesn't look too pretty. So instead, I focus on reduce the radical because we've been practicing that. And then we'll look at the result and see if they're all divisible by something. Because 104 is not a perfect square, so there is definitely going to be a radical in the final answer. So pull it off to the side. 104 is even. So 52. And then I don't know about you, but I played cards too much and I like numbers, so I know this is 4 times 13. 52 is one of my card numbers. It's also 2 times 26. There's 26 red cards, 26 black cards in a standard deck of cards. Or there's 4 suits. Each suit has 13, ace through 10, and then jack, queen, king. If you're like, what is she talking about? And you don't know what the cards are, that's okay. I'm just weird. I have, for those of you guys who are like, what? I have met people who don't know what the deck of cards is. So no making fun if one of your friends is like, I don't know. Some parents freak out about it, and actually rightfully so. The history behind the deck of cards is it was actually a ninja way to have a tarot deck without having a tarot deck, because, you know, back when witches were being burned, having a tarot deck like really stood out. You're a witch, and you're like, no, these are just cards. We play a card game with them. It's, you know, it's fine. So some parents, actually, there is a historical reason to avoid the cards if you are, you know, wanting to avoid that. All right. But ours, we end up with a 2, another 2, another 2, and a 13. So a pair of 2s is going to come out as just a 2. And then we are going to have 2 times 13 left inside the radical. 2 times 13 is 26. So what we have before we reduce is this. X equals, this is still negative 8 plus or minus. That 2 comes outside, and the 2 times 3 is 26 inside, all over 4. In order to reduce this, both of the terms on top have to be divisible by whatever you want to also divide the bottom by. So the 8 and the 4 do have the 4 in common, but the only number that we get to work with here is a 2. So 2 itself is not nicely divisible by 4, but all 3 of these numbers, 8, 2, and 4, are all divisible by 2. How you write that can go one of many ways. I know a lot of people just like put lines through all 3 numbers and write what the result is, and then write their solution, and I've done that when it's work on my own. What I prefer to emphasize in class, though, is When we reduce, we are dividing the top and dividing the bottom by a number. I'm not going to write divide by 2 everywhere. I'm going to factor 2 out. So 2 comes out of the top. This would leave -4 plus or minus the square root of 26. So this number has to factor out of both parts. And the plus or minus just stays with the square root. The bottom is 4. We could also write it as 2 times 2. I'll go ahead and do that. And now these, it's 2 times the top and 2 times the bottom. They're both doubled. So we knock out the 2's and say, now they're not. So this would be the reduced answer, the most simplified answer, which is the answer the computer then requires of you. -4 plus or minus the square root of 26 all over 2. And usually on these, Alex will give you a plus or minus button so you can just write it once. Like, it's annoying. When you're typing these, type the fraction first. It's like the biggest thing. So if you do the fraction first, then you go to the top and you can write the -4 plus or minus the square root of 26 and then go down and put the 2. Just a typesetting suggestion. All right, we got one more before we get to word problems. But look at the one more we have. Now I can hear it. You guys aren't even watching the video yet, and I can hear it. Why would you do this? I have good news. One, I would not do this, but I will tell you the horror story of the first time I did one of these. Because my math book, algebra, when I took it in 7th grade, because I'm a geek, we didn't ever have fractions with quadratics. So the first time I saw this, I was teaching. I was like, well, we can put the quadratics, the fractions into the quadratic formula. And we started working it with fractions, and it was just really bad. Really bad. And then I looked at the notes, which was photocopies from the book, and the book was like, it's an equation. Get rid of the fractions first. And I was like, oh my God. I spent 10 minutes torturing my students for no reason. So, learn from my horrible mistake. Get rid of the fractions. It's an equation, so we can get rid of the fractions. We just got to figure out what the common denominator is. So with 3 and 9, it'd be 9, but 9 is not going to cancel out. That's 6. 6 is even, so I'm going to take 9 times 2, 18. 18 is going to cancel everybody. So I'm going to multiply everything, both sides, by 18. 18 and 18. Then I'm going to distribute. So 18 times 1/3. 1/3 of 18 is 6, but I'm just going to write it for now. That is like the worst dot ever there. And f squared plus 18 times 2/9. And again, this is where your calculator can crunch this for you. We are picking the number that makes the fractions disappear, which even a regular calculator then, if you just crunch it on the calculator, the result should be a whole number, an integer. Might be negative, but it'd be an integer. All right, then 1/6 times 18, both divisible by 6, so we end up with 3. But I'll go ahead and write it. 1/6 times 18. All right. So when simplifying these, what I do is I focus on the division first, and we picked this number because each of these denominators divides into it, so start with that. Like if you're not going to use the calculator and you're doing it by hand, then start it that way. There's no shame in just pulling out the calculator. So divide by 3, divide by 3. 18 divided by 3 is 6. So this is now 6f squared. Then here, 9 goes into 18 twice. 2 times 2 is 4f equals 6 goes into 18 3 times, like I was saying before, so we have 3. And now notice 6, 4, and 3, there's not a common number between them. They're not all even, or they're not all divisible by 3. So this is the smallest integer quadratic that will have the same solutions as the original quadratic. So if we were graphing these, the graphs would be different, but the spots where they cross the x-axis would be the same. And it would literally look like like one graph would be kind of squashed and the other one would be more stretched, but the points on the x-axis hold firm. So it's like you're taking a thing and kind of stretching and squashing, but the x-axis always holds it. It's actually kind of cool to look at. All right, and to use the quadratic formula, we need to move that number over. So we now have a 6 for A, a 4 for B. Don't write the B, write the F. And minus 3 is equal to 0. Now our quadratic formula, we're going to go F equals, and I'm going to write it over here. F equals negative B is 4 plus or minus the square root of B, 4 squared, minus 4A, 6, C, negative 3. So it is going to work out to some number. It's not imaginary. All over 2A. After you get through like all this stuff on top, like sometimes your brain forgets A does go here. Double check that A was not 1. I know in most problems it is, but on the test, at least one of them it wouldn't be. Because that's our way to say, are you paying attention? Now we do have a negative 4 on top and a 12 on the bottom. So we're seeing these are both even. In fact, they're both divisible by 4. So if we can get a 4 or a 16, like an even number coming out, we're going to have to do some reduction, which I can already look up there. I got 4 squared minus 4 times something. There's at least a pair of 2's coming out of this result. 4 squared is 16. And then this is 4 times 3 is 12. 12 times 6, 6 dozen is 72. And then the negative times negative makes it positive. So 72 plus 16 is 88. Ooh, 88's very even. So that is 8 and 11. 8 is 4 and 2. So we got a pair of 2's. So 2 coming out. 2 times 11 staying inside. 22 for the inside. So F right now equals negative 4 plus or minus 2 square roots of 22 all over 12. And then I'm just going to do it the lazy way. Divide by 2, this is a 1. Divide by 2, this is a negative 2. Divide by 2, this is a 6. Negative 2. When it's down to a 1, you don't have to write the 1, so just square root of 22. It's not incorrect technically, but some computer programs will get persnickety about it. So there is our ridiculous solution. We did not do the decimals on any of these, did we? Bad teacher. At least I remembered before the video was over. All right. And turns out it's just number 2, number 4, and number 5. So what we need to do is we're going to have to type in on the calculator. Now, when you do this, so we're going to type 5 plus the square root of 29. Some calculators, when you type square root, are going to open a parenthesis. If it opens it, make sure to put an extra one to close it. And then we're going to close it. And then divide that result by 2. And then we're going to round that to the tenths place. I'm just saying tenths because that's what Alex was asking for. And I don't have my handy dandy calculator anymore, so I just use my phone because I'm the teacher and I can. You can also just, well, I got to switch it to scientific mode, don't I? So you can do 5 plus the square root of 29. Hit equals, and you get an ugly decimal, and then divide that result by 2. And in this case, it is unreadable by the camera, 5.192, blah, blah, blah. So tenths, it's going to go up. Yes, that was my roommate. 5.2. Now we also need to do the negative, so we're going to rewind, and now it is 5 minus the square root of 29, and that equals a negative number, which square root of 29 is bigger than the square root of 25, so should be a negative number, but not all the way past -1. Then we divide that result by 2, and we get negative 0.192 blah, blah, blah. And it's not uncommon to see here, it's because one's positive and one's negative that the decimals are the same. Usually they're kind of like mirror images of each other, and you're going to see in the graphing, it's because the graph is symmetric, and usually our center line is an integer. So the spacing from that integer is a positive and a negative, but it's equal, so that's why sometimes the decimals match. So it will be negative 0.2 for the other decimal. Now in Alex, they either asked you for one or the other, not both. Some of the fancy calculators will actually do the whole, like you type in the quadratic and it gives you the decimals. Just poof, answer. Some calculators is like a program you can download to do that. Which, me personally, I'm like, fair game, do it. Do the thing, use your tools. Why would anyone say, don't use the power drill? I want you to use the screwdriver. No one says that except mathematicians. You can't use the power drill on the test, so you shouldn't use it now. All right, so to calculate this one, we're going to go -4 plus the square root of 26. So let me clear that. -4 plus the square root of 26 is 1.09901 divided by 2, 0.549. So 0.549. Even though the 49 would round up, you only look at the number right next to it. 4 is not enough, so it's just going to be 0.5. And then rewind, and now it is -4 minus the square root of 26. And that's -9.099 blah, blah, blah divided by 2. -4.549. Again, same reasoning. This will be -4.5. They do not always have these mirrored decimals. It is only because one's positive and one's negative. If they were both positive or they were both negative, then it would have been like 4, 5, 0. It's basically like whatever the opposite number that would add to 9 is, that's what you would see as the like reflected kind of decimal, if you will. So there's our decimal equivalents to go with our exact answers. And then let's go ahead and see what the heck this one's going to be. -2 plus the square root of 22 divided by 6. All right, so our first one is 0.448. So that is going to stay 0.4 or 0.4. And then the other one is going to be -2 minus the square root of 22 divided by 6. And this is -1.115. So here it doesn't even add to a whole number, and that is because it's divisible by 6. So it means we didn't have an integer for the center line on this one. And in fact, this is the one that started with the ugly fractions, so but it'd be -1.1 then to round to the tenths. All right. One more video where I'm going to do crazy word problems. Hopefully I didn't mess them up like I did on the midterm. Again, I'm very, very sorry. I'm very embarrassed about number 3. Everybody is getting free 10 points for that because I screwed it up. So even if you turn something in, it's just a free 10 points, which also means I'm not actually going to look at your work on number 3, FYI. All right. I will see you for the next video.